Hi, I'm Justin. I'm going to do a short introduction into the safe use of drill drivers. Before starting any work using tools, you may want to consider tying back long hair, tucking loose clothing away, perhaps wearing a dust mask, and a pair of safety goggles. Okay, so the essential items you'll need for drilling will be a drill driver, which is this item. Here we have high-speed steel drill bit, a wood drill bit, masonry, ceramic. This is for plastics. And then we have a countersink, a bradawl for making marks. These are raw plugs, and expanding plugs for plasterboard, and then a little tool kit with your screwdriver bits here. So screws themselves come in 4 general types. We have a slot head, which is the flat one, a Phillips head, which is the cross, the PZ or posi head, which is slightly different as it has a starburst in it, and the tools associated are different as well, and then a hex head. It's always handy to have a spirit level, a pencil, and some masking tape to go along with that. And of course, a tape measure. So here is the standard battery drill driver. These can be found in fabrication, and also you can loan them from Central Loans. Very similar tool. They all have the same functions on them, which we're going to go through now. So to set it for drilling, you will see the functions start from back to front. So here we have a switch to switch over from 1 to 2 speed. So 1 being the lowest speed, 2 being the fastest. As you come down, there's usually an arrow markation or a line that shows you what else the settings are made to. So here we have a circle with a cross and a hammer, which means it's not on hammer. So this is your general setting for when you're screwdriving and drilling medium density materials. If you were to be drilling heavier masonry, you can index the sleeve one until the hammer is in line, and then you get an action which helps you drill through harder materials. So as you follow it down, you will see there's a little drill icon which shows you that it's set for drilling. If you were to use it as a screwdriver, you would generally index the sleeve here until you're on the numbered ratchet, and this is a torque setting for how heavy you want the drill to be used, and will push the drill in to a certain depth depending on the resistance of the material, which we'll go through later. On the side by the trigger, there's a little lever that goes back and forth. In the center, when you pull the trigger, it's on safety, so you can't hurt yourself if you always put it in the center when you're not using. If you're right-handed, you can push your finger in and push the little toggle through, and that will set it for drilling in the correct direction. So pulling the trigger. The good thing is, if you haven't quite set this one correctly, it's a progressive trigger. So if you only pull slightly, it only goes so fast, and you can control that. Using your thumb or pushing the toggle through to the other side will set that drill in reverse. At the bottom, you'll see the battery itself, and very often they'll have an indicator to show how much power is left. But to release it, very simple, you push a button and it will slide out, push it back to connect. And also, very handily, there's a torch which will light up where you're drilling. To put a drill bit in, you use the chuck mechanism here, and it has a little clamping device when you rotate it back and forwards. So you would place your tool in the clamp, turn the chuck, and then turn it until it's locked tight. With drill on safety, you can't hurt yourself while you're doing this operation.
Go.
Here are the tools and fixings you might use with a drill driver. So we have standard high-speed steel drill bit. This is for general purpose. It can cut through wood, metal, plastics, things like that. But ordinarily, if you're cutting through plastics, this is the better choice. It's Christmas tree or step drill. It pushes down rather than pulling up the material, so you don't get so much snapping or cracking of the material like plastics, things like that, very brittle materials. This is a wood drill bit, very similar to high-speed steel, but it has a point on the end to stop it sliding around or following the grain. Here we have a masonry bit. You'll see at the end there's a tungsten tip. That's hardened metal material for cutting into very dense materials like breeze blocks. This is a ceramic spear point drill bit for cutting through tiles, things like that. And here we have a countersink. So you'll notice at the top of most screws it's a bugle head. So if you want them to be flush with your material, just put a little countersink in afterward. These are known as roll plugs or expanding plugs. If you wanted to fix something to a wall, there's nothing to screw into, so these would go into the hole, and the information for the size hole you'll need for each of these type of items are actually written on this strip here. And they just snap off like so, and then the screw will then go into this and it will expand in the hole that you've drilled. If it's plasterboard, you may need a different type of expanding plug, but the principle's the same. This is for the drill or the driver. So we have a screwdriver bit, and very often you have to push or pull this part to locate the tool inside the actual driver bit. Now, choosing the correct drill bit for a pilot hole, you will see that if you offer it up to your fixing, that the thread can be seen either side of the drill bit, and so it's slightly smaller, and that way when you drill this one into the wall, this one will screw and bind onto the material. The screw hole needs to be slightly bigger than the fixing itself, and that way it will pass through without you having to turn the fixing. Using the drill, so safety first, we have a pair of safety specs to protect our eyes, and then I've marked a line here with evenly spaced markations, and this is just a piece of paper masking taped to the material to collect any dust that we're going to make. Now I've set the drill in the correct setting with a pilot drill, so this is for guiding the screw or the fixing when it enters the material. Sometimes with material, if you push against it, there's some slippage, so very often it's easier to just put a slight indentation into the material first, help you keep on your mark, or placing a piece of masking tape to create a bit of friction before you drill. So with the pilot hole, place it on the mark or the indentation, and then if you stand right over the top of it, you're not going to see if you're at a strange angle. So I stand slightly to one side to start, put it into drive, and then push it forward until I'm happy. If you wanted to do an angled guide, very same principle for marking, but you start the drill until it bites into the material, and then you can angle it to guide your screw at any angle, and then just move it along the wall to collect any dust. As you drill more holes. Swapping over to the countersink, I'm going to use that to create an indentation for the bugle head screw, and then swap over to my screwdriver and swap it over to a screwdriver setting. Usually start low, you can always increase it if it doesn't quite bury the screw, and then should follow your guide hole until it's flush. Leaving the screw slightly extended, you can use it as a hanger, and then to remove any screws, you switch this lever behind the trigger into reverse, and it should come out. Just be careful, it creates friction and heat in any item that goes in and out of material. So we're going to affix this batten to this piece of chipboard using screw holes and pilot holes for the hook fixings in here. So a screw hole is a hole that the screw will pass through without you having to turn it. This is so it only turns in the material you're actually affixing your batten or material to. So using a screwdriver bit, spin it like so, and you can see this is not hard fixed. A little bit of friction, and so it will stay up on its own. My spirit level then, to bring the batten level. Second screw here. To fix it into place. And then these are pilot holes, which are slightly smaller than the screw thread itself. And so you can twist your fixing or screw into position and it locks tight. Split battens are very useful hangers. It's easy to level because it's a long batten. You have one for the wall and you have one opposite one that hangs on your material. They literally slip over each other. There's adjustment, and then we use them for light boxes. Here's a little hack if you don't have a hanger for your materials or your frames. You can just use a ring pull from a can, and if you don't have any screws, you can hot glue it in position and then hang it on a nail on the wall.
Hello, it's Louisa from Fabrication. Right now we're going to go through some basic health and safety training for step ladders, and that's so that you can loan this kit from Central Loans at Bower Ashton.
When selecting your ladder location, please set it up on a clean, flat, non-slip surface. When selecting your location, make a visual check before you start. Check the stiles, rungs, straps and platforms, and remove any tape or debris on the ladder that could hide cracks and defects. Place your ladder square onto your work. Please don't use it side on so that it could fall out sideways and twist your spine. You should have 3 points of contact when using a step ladder. That would be 2 feet and a hand, or 2 feet and your middle. Maintain your 3 points of contact when ascending and descending the ladder. Choose your step ladder according to the height at which you want to work and never overreach. You may need to do a risk assessment and hire in a platform with your academics if we don't have the kit on site. Try and work with a buddy and never spend more than 15 minutes up a ladder. Please don't leave tools or equipment on the paint tray. The main cause of injury on this campus is from objects falling from the shelf. Do not use working at height equipment under the influence of alcohol, drugs or extreme fatigue. Please be considerate of where you store your ladder when not in use. Also, bend your knees when manual handling and moving your ladders around. Thanks for listening, folks. There's a short quiz now. Have fun.